Hello students, welcome to the next session. We'll start with question number 5 of exercise 4.6 today. This is a matrix given to us. We have to find out the system of equation, whether it's consistent or inconsistent. Let us write these particular equations in the form of matrices AX equal to B. Matrix A consists of coefficients of X, Y and Z written in this manner 3, -1, -2. Since X term is missing for the second equation, so we'll be taking its coefficient as 0. For this it will be 2 and here -1. Likewise 3, -5. Z term is not present, therefore its coefficient would be 0. For X, we'll be having X, Y and Z is equal to the constant value 2, -1 and 3. Our next step would be to find out the determinant value. So we'll find out the determinant value by expanding along R1. So we get the determinant value as 0. So this means the equation is, the matrix is a singular matrix. Our next step would be to find out the adjoint of matrix A. Adjoint of matrix A is the transpose of the cofactor of the various elements of this particular matrix. So just we'll write down the positional values first, and then for each element we'll be finding out the cofactor. So likewise it is 0, -5, here we have -5, likewise 3, -6, -10, 6, -12, 5, -3 and 6. We'll find out its transpose. This is the transpose. Our next step would be finding out the product of adjoint of A and B. So once we find out adjoint, remember this is matrix B. So we'll find out the product of the two. We get this as the product, -5, -3 and -6. This is not equal to a null matrix. This is not equal to 0. Therefore, what can we infer? We can infer that the given system of equation is inconsistent. Remember, we had two options, either adjoint of A into B is equal to 0. Then the system would have been either consistent or inconsistent. But if it is not equal to 0, remember it is always inconsistent. Right? So with this, we find out the inconsistency and the consistency of the equation, given system of equations. Next, we move on to finding out the inverse of the given equations using matrix method. Now, remember the matrix method exists only when A inverse exists. And A inverse exists when determinant of A is not equal to 0, or we can say when a matrix is non-singular matrix. Again, our very first aim would be to represent a given equation in the form of AX is equal to B, right? So AX is equal to B, so this is 2, -1, 3, 4. This is X and Y, and B is 2 and 3, right? Now, as we already know, how can we find out the value of X? By finding out or by establishing this relation, X is equal to A inverse B. And how is this possible? If I pre-multiply AX B with A inverse, right? So what do I get? A inverse A into X, that is IX is equal to A inverse B. And identity matrix into any matrix gives us the matrix itself. So X is equal to A inverse B, right? So we will memorize this particular expression to find out the inverse using matrix method, right? So what is our X? It consists of variables. Inverse, we are supposed to find out the inverse of matrix A. So that is 2, -1, 3 and 4. And B is 2 and 3. That's -2 and 3. Right? So, first of all, how can we find out the inverse? By the formula adjoint of A upon determinant of A. Right? So, first of all, let us find out the determinant value to see whether the inverse exists or not. So, it will be 8 minus -3. So, that's 11, which is not equal to 0. Therefore, A inverse exists. Now, let's find out adjoint of A. Since this is matrix A, its adjoint, these are the positional value, positive, negative, negative and positive. We have to find out its transpose. Eliminate this. What are we left with? 4. Eliminate this. We are left with 3. Eliminate this. We are left with -1. Eliminate this. We are left with 2. Finding out its transpose gives us 4, -3, 1 and 2. So this is adjoint of A. A inverse would be 1 upon 11 4, 1, -3, 2. Right? Remember, X equals to A inverse B. A inverse is 1 by 11, 4, 1, -3 and 2. And what is B? Matrix B is -2, 3. Right? So let this 1 by 11 be here. 4 into -2, -8 plus 3. Likewise, we have 6 plus 6. This is X and Y. So we have X and Y here is equal to, this is -5 and this is 12 and 1 by 11 over here. Or we can write it as -5 by 11, 12 by 11. Or simply we can say on comparing, X is equal to -5 by 11 and Y is equal to 12 by 11. Right? So this way we'll be finding out the solution for the linear equation using the matrix method. Remember, this particular method is known as the matrix method. Right? With this, we move on to question number 11. We come to question number 11. Again, this is a linear equation in 3 variables. So we have to represent it in the form of AX is equal to B. Right? So we have matrix A, 2, 1, 1. This is 1, -2, -1. This is 0, 3 and -5 as X value, X term is missing. Here we have X, Y and Z, and here we have 1, 3 by 2 and 9. So we know X is equal to A inverse B. So let's find out determinant of A first, because to find out the inverse we need to know the determinant, whether inverse exists or not. For that, let us expand along R1 again. So eliminating this, we have 10 minus -3. So that's +3. -1, eliminate this. This is -5. This is 1. Eliminate this. So this is 3. So 2 into 13, that's 26. Plus 5 plus 3. 26 plus 5 gives us 31. 31 plus 3 gives us 34, which is not equal to 0. Therefore, A inverse exists. So our next step would be to find out adjoint of A. Remember, we'll be finding out adjoint. Mark the positional values. Eliminate this. We have 10. That's 13. Eliminate this. This is -5. Eliminate this. This is 3. Likewise, eliminate this. -5, -3, -8. Likewise, eliminate this. We have -10. Eliminate this. We have 6. Again, eliminate this. So we have -1, -2. So -1 plus 2 gives us 1. Likewise, eliminate this. This is -2, -1, -3. Eliminate this. Again, we have 4. -4, -1. That's -5. Finding out its transpose. So that is 13, 5, 3, 8, -10, -6, 1, 3 and -5. What is A inverse? It's adjoint of A upon determinant of A. Determinant is 34. So it's 1 upon 34. 13, 5, 3. 8 minus 10 minus 6. 1, 3 and minus 5. Remember, x is equal to A inverse B. Right? So x has x, y and z variables. A inverse. So that's 13, 5, 3. 8 minus 10 minus 6. 1, 3 and minus 5. And B consists of 1, 3 by 2 and 9. Right? So finding out the product, remember this is 13 plus 8 into 3 by 2. 2 4s are 4, 3, 12 plus 9. Likewise, this is 5 minus 15 plus 27. And this is 3 minus 6 minus 9, and that's minus 45. So we have 1 by 34, and this is 13 plus 12, which is 25. 25 plus 9 is 34. This is 27 plus 5. 27 plus 5 is 32. 32 minus 15, or we can say 5 minus 15 is minus 10. That's 17. And this is 45 and 9 minus 54 minus 51. Right? And what is this equal to? This is equal to x, y and z. So if I compare, remember, x is equal to 34 by 4. 34. Y is equal to 17 by 34. And z is equal to minus 51 by 34. Right? So we have this equal to 1, this equal to 1 by 2, and this is equal to minus 51 by 34. So that's 17 2s are 17 3s are. So that's minus 3 by 2. So we can write x equal to 1, y equal to half, and z equal to minus 3 by 2. Right? So this is how we calculate the values using matrix method. I hope it is clear to you, students. Next, we'll be taking up question number 14. Again, this is a 3 by 3 matrix to be represented in the form of AX is equal to B. All these questions are similar to one another, so you can practice them the same way. The same method needs to be followed. So matrix A consists of 1, minus 1, 2, 3, 4, minus 5, 2, minus 1, 3. X consists of X, Y and Z is equal to 7, minus 5, 12. So X we have to find out, which is A inverse B, right? Let's find out the determinant value. Expanding along R1. So we have 12 minus 5. Minus 1, which is plus 1. So this is 9 minus 10. So that's plus 10. Plus 2. That's minus 3 minus 8. So this is 12 minus 5. That's 7 plus 19 minus 11. So that's minus 22. Right? 19 minus 22 is minus 3. 7 minus 3 gives us 4. Which is not equal to 0. Okay, therefore A inverse exists. So next step would be to find out adjoint of A. Remember, find out the positional values. So if we find out the positional values, this will be positive, negative, positive. For this, it will be 7. For this, it's going to be 19. For this, it's going to be minus 11. Right? Let's find out for these. So this is minus 3 plus 2. So that's minus 1. Likewise for this is 3 minus 4, minus 1. For this, it's going to be minus 1 plus 2. So that's 1. Likewise for this, it's 5 minus 8, minus 3. For this, it is minus 5, minus 6, minus 11. And for this, it is 4 minus 3, that's 4 plus 3, that's 7. Its transpose will give us 7 minus 19 minus 11, 1 minus 1 minus 1, minus 3, 11 and 7. Now inverse. A inverse is 1 by 4, adjoint of A upon its determinant. So let's find out x is equal to A inverse B. X is x, y and z. A inverse, that's 1 by 4, 7, 1 minus 3, minus 19 minus 1, 11, minus 11 minus 1, 7 into B, which is 7 minus 5 and 12. Finding out the product, 49 minus 5 minus 36. Likewise, minus 133 plus 5, thus 132. Likewise, this is minus 77 plus 5 plus 84. Okay. Therefore, we can write x, y and z is equal to 1 by 4, 49 minus 5, or we can say minus 36 minus 5 is minus 41, 49 minus 41 is 8. 1 minus 133 plus 132 gives us minus 1 and 5 minus 1 gives us 4. Likewise, 84 minus 77 gives us 7 and 7 plus 5 gives us 12. So we have x, y and z equal to 8 by 4, 4 by 4 and 12 by 4. Therefore, x is equal to 8 by 4 which is 2, y is equal to 4 by 4 which is 1 and z is equal to 12 by 4 which is equal to 3. This way we find out the solution using the matrix method, right? These questions, question 2, 3, 5, 6, 7, 9, 10, 11, 5 has been done, 11, 12, 13 and 15 will be done using the similar method, right? So these are for the practice which can be done easily, right? Let me form the equation for question number 15. Okay, so we have question number 15, that is the cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60, right? So if we take, let one kg onion cost rupee X, let 1 kg wheat cost rupee Y and let 1 kg rice cost rupee Z, right? So our first equation will be the cost of 4 kg onion, that is 4x plus 3y plus 2z is equal to 60. Likewise, cost of onion 2x plus 4y plus 6z is equal to 90 and 6x plus 2y plus 3x 3z is equal to 70. Find cost of each item using the matrix method. So means we have to find out the value of x, y and z. We have formulated the equation. So our matrix would look of the form Ax equal to B. A will be 4, 3, 2, 2, 4, 6, 6, 2 and 3. Right? Matrix X would look like X, Y, Z and B would look like 60, 90 and 70. Likewise, you will be finding out A inverse x is equal to a inverse b to calculate the value of x, y and z. For that you need to find out the determinant value. I hope it is clear to you students. This was just a hint for question number 15. Please practice these questions. And matrix method is like one very important method. So please practice these questions very, very carefully. Okay. Thank you so much.